I don't have any homework tonight. I forgot and did it all.
Okay. What kind of stuff are you working on? Maybe I can make some stuff up.
We are working on graphs.
Okay.
We are working on things in the graphs like uh, stretching and shrinking or
Okay. Are you working with linear functions or quadratic functions?
linear. Linear.
All linear? Okay. That's a tough place to illustrate stretching and shifting in that.
Yeah.
Let's make one up. Now, if I want to stretch this,
We're actually working with f of x.
good.
Uh,
I'm just going to say, because f of x is a much, much better way to describe these.
yeah.
Here's the reason. What does minus f of x mean?
We haven't been told that.
Okay, there's 6 things you can do when you're doing these things. I'll go over all
Oh yeah, it's a reflection. Sorry.
over
I thought you were talking
it's
reflect over the axis.
x, which is a vertical reflection. Keep that in mind. If I have some c times f of x, that's also vertical. What is that?
It is either it's a stretching or a shrinking.
Stretch or shrink. Okay. And if I have f of x plus some constant,
That is transitioning.
that's a vertical shift.
Oh yeah, sorry. Vertical shift.
Notice that all 3 of those are
Are
vertical and
because
everything is outside the function. Okay,
everything that's
so
inside it is horizontal.
yeah, so f of negative x is what?
It is a horizontal reflection.
Yeah, and that's one way to just call it, is a horizontal reflection, which means over the y-axis. And if I have f of some number multiplied by x that's inside the parentheses, what is that? It's also horizontal.
That is going, yeah, it's a horizontal stretch or shrink.
And it's important to know that in this case, if c is greater than 1, it's a stretch. If c is less than 1, it's a shrink.
Yeah.
In this case, it's the opposite. If c is greater than 1,
Yeah,
it's a shrink. If c is less than 1, it's a stretch. So just make sure
because
you
whatever
remember.
happens inside the parentheses is the opposite of what you think it will happen.
Okay, it doesn't matter how you remember that, but let's see. The other thing you can do is, let's see, we've got a horizontal reflection. Oh, is a shift, x minus c. And that is the same as a horizontal shift. Now, let's look at some of these things. Shifts do not change the shape of the curve. Whether they're vertical or horizontal, they do not change the shape of the curve. Hold on. Okay, cool. So what I have check marked here, now let me uncheck mark that. So the ones that don't change the shape are that one, that one, that one, and that one. The only ones that change the shape are stretches and shrinks. The other 4, in other words, if I start with a shape like that, then I may make it like that if I horizontal or vertically reflect it, or I may make it, down some, but I don't change the shape of the curve. Whereas if I stretch it or shrink it, I do. In other words, if I stretch it, that curve looks like that, which is a different shape. You know what I'm saying?
Yeah.
That's a key consideration in all of these. Because when you go to graph these changes, it's important to know whether you're just taking a curve and shifting it up or down, or right or left, or if you're stretching it or shrinking it. What would a shrink look like? A shrink would look like this. That also
It
changes.
would get farther away from the axis.
It flattens it, yeah. You can think of a stretch, a vertical stretch as making it skinnier, and a vertical shrink is making it flatter. Now, when you're looking at linear functions only, it's kind of different. It's hard to tell the difference between horizontal and vertical shifts. Let's take that line right there, okay? If I want to move that up 2 units, and that has a slope of 1, well, is that a vertical shift or is it a horizontal shift?
It would be a...
It's both. Neither one takes priority. It is either a vertical shift up by 2 units or a horizontal shift to the left by 2 units. This point right here is -2. Okay? So with straight lines, you don't really see a whole lot of these transformations. It's hard to tell. And it's confusing. I would prefer if they waited until you at least got the parabolas or square root functions. If you take a square root function, all 6 of these things make the curve look different. Every one of them. You'll end up with 6 different curves here if I start with the square root function. But if I start with a straight line, notice something else about this straight line. If I start with the straight line there and I reflect it over the x-axis, it looks like that, correct?
Yeah.
Okay. If I reflect it over the y-axis, it also looks like that. So reflections, as long as that slope is 1. If that slope were 2, then that wouldn't be true. But as long as the slope is 1, then reflections, it's hard to distinguish between a vertical or a horizontal reflection. So straight lines really are not, you know what a square root function looks like, right? Let's deal with the square root.
Yeah, I think.
Yeah, this is what a square root function.
I haven't really worked on it in class.
Okay. Now let's apply each of these and you'll see they're all different. If we reflect over x with blue, that's what it looks like. If we stretch the black line with green, then it becomes steeper like that. In other words, that's green, that's blue, and we'll make the shift red. If we shift it vertically, then it might look like that. Notice no change in shape. The only one of those that changed the shape was the green. Okay. So the red goes with that. Now let's look at the horizontals. I'll use the same 3 colors. I'll use blue for a horizontal reflection of the black. I'll use the green for a horizontal stretch of the black. And actually, this is one case where it's hard to tell the difference between a horizontal stretch would be making it flatter. I knew I was going to do that. So there was the vertical stretch. Horizontal stretch will look like that. And finally, a horizontal shift of the black might look like that. Again, no change in shape. So you'll notice that every single one of those lines is different. In other words, all of these translations for this particular function, and this function is y equals square root of x. There's your parent function, your elementary function that we're making all of these adjustments to. And this covers every function. In other words, every one of the 10 elementary functions you can do these 6 things to. Whether you've learned all 6 of them or not yet, doesn't really matter. You will. That's where you're headed. It's just that they're tough to see when you're looking at just straight lines. Unless, of course, you have a straight line that doesn't go through the origin, then it's a little easier. In other words, if my function is, say, y equal 2x plus 1, well, there's 1. It's a slope of 2, so my black line would look something like that. And now, if I vertically reflect that, I get that. If I horizontally reflect it with blue also, I get this. So horizontal and vertical reflections are a little different. Now you see how I got each of those?
Yeah, because they both crossed through
Know that this
the line.
point has to be the same when you're doing reflection over the x-axis. And every point there has to be the same distance from the x-axis, so this distance is the same as that distance. That's how you do a reflection over the x-axis, and you do the same thing over the y-axis, knowing that this point has to be the same on both the original and the reflection. But when you start doing shifts, vertical shifts still look very similar to horizontal shifts. And it's hard to really tell much with the function being linear. So this is one case where you're actually better off using a more complicated function like y equal x squared. You can see more of these 6 transformations if you use y equal x squared. In fact, let's do that because surely that's coming up next. You may have not had the square root function so much yet, but I know you've had y equal x squared, which is a simple parabola with its vertex at the origin.
We actually haven't worked with parabolas yet.
Well, you'll see something about this. That's what this is a parabola. And you'll notice that if I do a reflection over the x, it looks like that, correct?
Yeah.
But if I do a reflection over the y, it looks exactly the same as the original parabola. So even a parabola is not complicated enough so that everything's different, if you know what I'm saying. In other words, the reflection over y looks exactly the same as the original function does. Whereas with the square root function, all 6 things look different, which is key if you're trying to understand the significance of each of these 6 things. It's nice if they all look different. You know what I'm saying? Okay, here's what the problem becomes. What if I give you a problem like this, and I say, what's happening? If my parent function is y equal x squared, then what does this do?
It shifts it up.
It's a vertical shift.
Shiftly.
Okay, cool. Let me give you another one. that?
Well, if you're making a table, then it
No,
or
it's important to realize
reflects.
that what we're looking at is
It
minus
reflects.
f of x, which makes it a vertical reflection.
Yeah, sorry, that's what I was saying.
All right. You don't need a table, in other words. In other words, the key to answering all of these is to put them in terms of f of x. Okay? If f of x is equal to x squared, that's my parent function, and I tell you that I have some g of x that's equal to negative x quantity squared, what is that?
It horizontally shifts over the x-axis.
Yeah,
I mean,
notice that if I multiply that out, I get the same function. That's why when I took my parabola and I reflected it over the y-axis, it looked exactly the same, because it is. They're both x squared. When you take minus x and multiply it by itself, it becomes x squared. And other type problems that you'll look at, the secret is to be able to take the function and figure out how to back it up into f of x notation. Okay, so let me give you one more here. Let's see how clever you are. What's happening there?
I forgot the name of it, but it horizontally translates 3 to the right.
Correct, horizontal shift. How about this?
It's oh god, I can never remember the names of them.
Vertical stretch.
Vertical stretch.
Always
By a factor of 2.
remember that your verticals are always outside the function. That's outside the x squared. Your horizontals are always inside the function. So if I did this, that's inside the function, right? That's a horizontal what?
That is a horizontal shift.
Shrink. Shrink. Remember, numbers greater than 1 are shrinks. Numbers between 0 and 1 are stretches. So if I go back and I say, what is y equal x squared divided by 2? What is that?
It is a shrink.
Vertical shrink.
Vertical shrink.
Make sure you specify vertical or horizontal, because they mean very different things. In fact, a horizontal shrink looks a lot like a vertical stretch. They have similar effects. They make the curve skinnier, the parabola. All right, that actually covers it pretty good. Let's see if I can think of some others where you have to go in this direction. In other words, by this direction, I mean they give you a function, and they may not even tell you what the parent function is. They may just give you that, and you have to figure out what the parent function is. In other words, let me make up, what other kinds of elementary functions have you had besides linear?
That's it.
That's it? All right, let me make one. Let me make up a linear one. What's the effect of the 2?
The 2 is
Vertical or horizontal? Always figure that out first.
It's vertical.
Okay. Is it a stretch or a shrink?
It's a stretch.
It's not a shift, right? Shifts are when you add to the end of the function. Add or subtract. So it's a stretch. So how would that look? Well, let's plot the linear function. That goes through -4, has a steep slope of 3. So that's what the original function looks like. And you said it's a vertical stretch. What's that going to do?
It's going to make it the line closer to the y-axis.
and it's going to change the slope. Notice that if I multiply that out, I get 6x minus 8, right?
Yeah.
Well, if I plot 6x minus 8, there's the minus x. It's much steeper, twice as steep. So that's what a vertical stretch looks like when you're doing straight lines, is vertical stretches change the slope by the amount of the stretch. That's the most significant thing. So you
Yeah.
don't really change the shape. You never change the shape of a straight line regardless of what you do to it.
Yeah.
But you do change the slope of a straight line with vertical stretches.
Yeah.
And if we had, let's stay on linear, because linear can be a little tricky sometimes. Let's make that a 2. Let me erase the parabola, or the quadratic. Let's assume they give you this function. I'm going to rewrite it. 2x minus 4. Can I figure out what the elementary function, in other words, there's a lot of ways to think about this. That's just a straight line that goes through minus 4 with a slope of 2.
Mm-hmm.
But what if I wrote it like this? Now it becomes a vertical stretch of this straight line, which is a totally different straight line. But in other words, you can take these and play around with them so you end up with vertical stretches on a different line by factoring out a 2 there. What if I had this? Let's see. If I had a line that had like that, slope of 1, and I wanted to reflect that over the x-axis, what would it look like?
It would basically look
What's
the same.
negative y? That reflects it over the x-axis, right?
Yeah.
Negative
Y.
What's negative y? If y equals that, put a negative sign in there and distribute it. What do you get?
It would be the same place, right?
No? In other words, here's what we start with. I'm glad we covered this. That's what we're starting with. Or I could even call it f of x, okay?
Wait, sorry, my computer's...
Negative f of x. Well, it's negative whatever your function is. Your function in parentheses is x minus 4, and now I have to distribute that negative sign, so I get minus x plus 4, and I can rewrite that as 4 minus x. So that is the reflected line, because that's what negative y does, is reflects vertically over the x-axis. And as all you do is you take your function, put it in parentheses, stick a negative sign in front of it, and then distribute the negative sign, just like I did here.
Okay.
Okay? Just make sure that you use parentheses, because this negative sign has to be distributed to the x and the negative 4. So if you don't have any parentheses in there, you're going to end up with the wrong answer. If I drop my parentheses, then I end up with that, which isn't correct at all. In other words, minus x minus 4 is not the correct answer. All right, Logan, I'm going to let you go. Looks like you're doing pretty good in this. You enjoying the algebra class?
Yeah,
Yeah, it seems like you're on top of it pretty good, and that's the secret to enjoying it, is to make sure you keep up with it. All right, I will talk to you next week.
Okay, you too. Bye.